Now we come towards case number 5, that is assuming M1 is greater than M2. So M1 is greater than M2, that is left side is M1, right side is M2. And you will always remember that tension is always against the weight. Acceleration towards the left portion is downward, whereas towards the right portion it is upward. The bigger mass is M, its acceleration is towards the left pulley, tension T1 towards the left and tension T2 towards the right. We are assuming M1 is greater than M2, so obviously mass will start moving towards the left. So M1G minus T1 equal to M1A, then T2 minus M2G, that will be M2A, T1 minus T2 will be MA. In all such cases, the point to remember is, if the two forces are acting in same direction, we add them. But if two forces are in the opposite direction, then from greater force, the smaller force is subtracted. These facts are applied in all these cases. Now solving equation number 1, 2 and 3, we get acceleration. Acceleration is given by function, that is force is mass into acceleration. So acceleration is force by mass. Now T1 is calculated as M1G into A, that is 2M2 plus M over M1 plus M2 into M. Similarly, T2 is calculated and we find that it is M2G, and within the bracket, instead of 2M2 and plus M, we take 2M1 plus M divided by M1 plus M2 plus M. Now we come towards case 4. Case 6. Mass suspended over a pulley from another on a smooth inclined plane. When we speak inclined plane, it's a kind of wedge shaped. So now in the figure or otherwise, we will say that mass suspended over a pulley from another on the smooth inclined plane, that is M1. So M1G minus T is equal to M1A. For M2, T minus M2G sine theta, that is equal to M2A, and solving the two equations in order to get A. Again, we use the method of substitution and elimination, and we can find the value of A, which is M1 minus M2 sine theta into G over M1 plus M2. Now, T is equal to M1 M2 into 1 plus sine theta into G over M1 plus M2. That is, we have put the value of acceleration in second equation for M2 and we got this value. Now, the important note is, if A is 0, that is A is 0 when M2 sine theta is equal to M1, M2 moves up the plane when M1 is greater than M2 sine theta, and M2 moves down the plane when M1 is less than M2 sine theta. So in the figure, the depiction is a inclined plane, M2 is the mass, then normal to the surface it is N, and normal reaction is, then weight is M2G, and M2G is resolved into two components, the horizontal and vertical. So one of the component is M2G cos theta and other is M2G sine theta. So N is controlled by M2G cos theta and T is controlled by M2G sine theta. And the load is suspended when the string is passing over the pulley. A is the acceleration downward and T is the tension upward and mass is M1. So obviously the weight is acting vertically down and this weight is M1G. And the conditions are given to us. If M1 is less than M2, then M2 will slide down the plane. And if M1 is greater than M2 sine theta, then M2 will slide up the plane. Now we come to case number 7. Masses M1 and M2 are connected by a string passing over the pulley, and our assumption is M1 is greater than M2. So now in the figure, again the same thing is there. We have taken two components, M1G sine theta and M1G cos theta. However, we are taking the alpha, so instead of writing theta, we should write alpha. Normal reaction is N, that is at 90 degrees to the surface, and M1G is the weight acting vertically down. M1G is resolved into two components. one of the component is m1g cos alpha and other component is m1g sin alpha. Now, if we will find that m1 is greater than m2, then m2 will start moving up and m1 will start coming down. So again, the principle of pulley is being applied, which I have explained earlier. Now towards the right side, the angle is beta. So here, in that one, the masses are including the horizontal and vertical components in terms of beta. Reaction is always at 90 degrees to the surface, and reaction is controlled by that is mg cos theta or mg cos beta. For m1, mg sin alpha minus t is equal to m1a, and for mass m2, t minus m2g sin beta is equal to m2a. When we use the term m1a or m2a, basically force is mass into acceleration. That concept is being applied here. And when we say m1g sin alpha minus t, obviously m1g sin alpha is greater than t. And when we say t minus m2g sin beta, it means t is greater than m2g sin beta. Now, we can calculate acceleration from these equations by method of substitution and elimination. So, we get the equation of acceleration, then putting the value of acceleration in one of the equation, we get the value of tension, and if A is 0, when m2 sin alpha is equal to m2 sin beta. If m2 is cancelled off, sin alpha will be equal to sin beta. Now case 8. From case 6, we know that tension is m1 m2 over m1 plus m2 into g. If x is extension in the spring, extension means increase, then t is equal to kx and x is equal to t by k. So we compute the value of t. We compute the value of t from the above equation, that is m1 m2 over m1 plus m2 into g, and then divided by k. So it is shown in the figure. Again, n is the normal reaction to the surface, m1g is the weight, normal reaction n balances m1g, t is the tension, and t1 is the tension on the string towards the spring side, and m2 is the mass suspended with spring. So obviously its weight will be m2g.